All right, so this question once again is asking us to identify the type of growth pattern that is seen in the table. Is it linear, exponential, or quadratic? We also need to use the phrases constant rate, growth factor, or constant pattern to kind of describe what is how we have identified the growth. So we always do this by looking at our output values to see how our output values are changing. And so in this case, when you look at your output values, that 1 became 2, 2 from 2 to 5, 5 to 10, 10 to 17, 17 to 26. So if we examine what's going on, or x values increase by 1 all the time, and sometimes we need to just really pay attention to how our x values are increasing because that can be tricky. And when we look at our y values, um, there's no multiplier, so numbers are not multiplied by another number that produces all our output values, but we do notice that there is a pattern with how the values are increasing by way of addition. So the rate of change, or answers here in yellow, has a specific pattern. They're all increasing by 2. So we can say that this pattern, since the output values are not changing at a constant rate, but the rate of change changes by a constant value of +2, then this table represents quadratic growth. And remember, what we said about quadratic growth is that quadratic growth shows this kind of constant change in or rate of change, but also one thing we know about quadratic, which we're going to continue to explore, is that there's a squared term in the pattern. So x squared plus what's going on here. So we're going to learn how to figure this out.